Hello everyone. Before you even start this video, could you please make sure that you have your formula sheet out? Should be the green piece of paper that I made for you a while ago. You will need the formulas for distance and midpoint and slope. So it would best to be have your formula sheet out. So pause this video and do that. And now let's get started. Please remember there's 5 properties of a parallelogram. And so if I have to justify if something is a parallelogram, there would be 5 ways to show it. And one way would be to show that both pairs of opposite angles are congruent, that both pairs of opposite sides are parallel, or both pairs of opposite sides are congruent. Or what I could do is show one pair, one set, is both congruent and parallel. So if that's the case, then it would have to be a parallelogram. And my last way to show would be that the diagonals bisect each other. So what do I mean by this? Here's an example of our first problem. And the first thing I want you to do is go ahead and graph these points and connect your dots. So hopefully you got something similar to me. And of course, yeah, it looks as if it is a parallelogram. But the directions are the vertices of quadrilateral A, B, C, D are given. Prove that this quadrilateral is a parallelogram by showing both pairs of opposite sides are equal. So if I need to show that opposite sides are equal, then I need to show that they have the same length. And the only formula we use to show length is the distance formula. So on this problem, if you'd like me to guide you through it, fine. But if not, you could pause the video here and try yourself to find the distance of all sides. So for example, if you don't remember the distance formula, it is x2 minus x1 plus y2 minus y1. So if I'm doing the distance of AB, I'm going to take -3 minus a -3, which is why this is plus, and then I'm going to take 4 minus 0. That's going to come out to be 0 squared plus 4 squared, which is just 4 squared, which is 16, and the square root of 16, which is 4. Now, yes, we had to do that for AB, but in order to justify that this is a parallelogram, I now need to show that CD is also 4. So I'm going to do that by showing that CD, the one that is opposite it, is the same length. So if I do CD, I would get 3 minus 3 and -5 minus a -1, which is plus. So I would get 0 squared and -4 squared. And remember, when we take that negative and square it, it becomes positive. So it's the square root of 16, and that answer is also 4. So right there, I've showed that they're both 4. The other thing is this: because these are vertical, you could have actually just counted 1, 2, 3, 4, but I probably will not put a vertical line on a test or quiz, so it's good to know how to do it. Now I would like you to take a second and try on your own to do BC and AD. And we can't count them because they are not horizontal or they're not vertical, so you have to use the distance formula. So I really hope you did pause the video and try to do these by yourself. But AD would be a 3 plus 3 and a -5 minus 0. That would give me a 6 and a -5, which is the square root of 61. 7.8 is a fine answer. Even if you're just justifying, the square root of 61 is absolutely fine. And then when I do BC, it's going to be a 3 plus 3, but a -1 minus 4, which comes out to be 5. So again, it's that 6 squared, -5 squared, which is 61 and 7.8. So anytime my picture is asking me to prove that they are equal, you have to remember that you use the distance formula. Let's try another problem. In this problem, I ask you to prove that it is a parallelogram by showing the opposite sides are parallel. And I want you to kind of pay attention to the directions, because my directions tell you that it is a parallelogram. I'm not really asking you, I'm telling you to prove it to me. So it should work out. And if it doesn't work out, you're probably doing something wrong. Well, to prove something is parallel, we have to use the slope formula, which is on your formula sheet. It will not be on my test, but you can use your formula sheet. So I have to prove opposite sides are parallel. So if I want, I'm going to start with the slope of AB. And so that's -3, 3, and 2, 5. So remember, it's rise, which is the y's, over the run. So I'm going to start by doing a 5. I'm going to start with B and take 5 minus 3, and then take 2 minus a -3, which is plus. That gives me 2/5. Well, what am I comparing AB to? I'm comparing it to CD. So when I do that, I'm going to start with C, and I'm going to take 2 minus 0 and 5 minus 0, and that gives me 2/5. As long as they are parallel, that starts my justification. Then I have to show, so what I prefer you to do is pause the video right here and try on your own to find the slope of BC and AD. So hopefully you got that when you do AD, I took 0 minus 3 and a 0 plus 3 because it's minus a negative, and my answer is -1. And when I did BC, I took 5 minus 2 and 2 minus 5, and my answer was -1. So if my directions ask me to prove something by the fact that they are parallel, I am going to use slope. And this may sound a little familiar because we did do this when we were trying to prove whether or not something was a right triangle, and we proved using perpendicular and parallel slope. So for the next problem, this asks you to show, please remember, I forgot that you should be graphing these every time we change the slide. And now I ask you to show that this is a parallelogram by showing that the diagonals bisect each other. Well, if these diagonals bisect each other, then they're going to intersect at the same point, at both their midpoints. And that midpoint would be the same point on the graph. So by showing if they bisect each other, I am going to use the midpoint formula, which you also have on your formula sheet. And so all I need to do is show the midpoint of BD. So up here's B and here's D. So I'm going to add my x's, which is -3 and 3, and then divide by 2. I'm going to add my y's, which is 4 plus a -5, or 4 minus 5, and that gives me the ordered pair at 0, -1/2. This would be like right around here. And then if I show that is the point, then I need to show that AC also has the same point. So for AC, here and here, I take 3 plus a -3 divided by 2, and I take a -1, 0, and I add them together and I divide by 2. So both come out to be exactly the same midpoint. I know this slide might take you a second, so pause the video and go ahead and do the math on your own. So if I'm asking you to prove by bisecting, then we're going to use the midpoint formula. For our next problem, if you read the directions, it asks you to prove that one pair is both congruent and parallel. Because if a side is congruent and it's parallel to each other, then there's no way that it couldn't be a parallelogram. So by doing this, we already did this, but some people might find this easier because you only have to do the distance formula of 2 sides. But whatever 2 sides you choose, you have to do the slope for those same 2 sides. So I chose, for example, AB and CD. So when I do AB, I found my slope by taking, for AB, I took 4 minus 0 and 0 plus 5. I got 4/5. For CD, I took -4 minus 0 and -2 minus 3, and I got 4/5. So that proves they're parallel. To prove they're congruent, I want to use the distance formula. And when I do that, it has to be of the same sides. So go ahead, stop the video, and do the distance formula yourself, which will give me 0 plus 5, which is 5 squared, and 4 minus 0, and that will give me 4 squared, and that's the square root of 41. Pause the video and go ahead and do CD on your own. And you should have got that it is also the square root of 41. The next side says, I want you to do it, and I want you to do it by yourself. I'm not even going to put up the answer. I'll talk about it tomorrow when I bring us all together, but I want you to try 6 by your own. So the problem is you can show that both sets of opposite sides are congruent by using the distance formula of all 4 sides. You could also use that opposite sides are parallel, so you could show the slope of all 4 sides, or you could show that the diagonals bisect each other and try to find the midpoint of DB or AC. So pause the video and go ahead and do that, and then we have one more problem to do together and we're done. For this last problem, the thing that's most important is that you should graph this picture, because it'll show you basically where the point needs to go. I give you 3 out of 4 points of a parallelogram, but I'm missing the 4th point. So after you plot these, you'll see that this is what your parallelogram should look like. Well, hopefully you could see the point should go somewhere up here, but I need the exact location. So there's 2 ways to do it. Since this is horizontal, I could easily count from B to A is 1, 2, 3, 4, 5, 6. Well, I could go up to 6 and count over 1, 2, 3, 4, 5, 6 and put my point right here. So my answer would be -3, 2. But if it is not horizontal or vertical, it's probably best to use the slope of the side that is parallel to it. So if I can figure out what the slope of CB is, then I could go to A and move exactly that slope. Well, guys, it's on a coordinate graph. You can count it. So I could go 1, 2, 3, 4, 5, up 5 over 1. So from here, I could go up 5, 1, 2, 3, 4, 5, and over 1. Now, I did just show how to get the slope of CB. I would take 2 minus a -3, which is 2 plus 3, and 3 minus 4, which is 1, so that's -5 over 1. So if I had to go, what you have to remember, it's rise over run. So if I go up 5, you have to go that -1, which is to the left. And then that's where my ordered pair would be. Okay, so you do have to know how to do that style problem as well. So make sure you have problem 6. That's something I'm going to check tomorrow. And hopefully you got that done.